Welcome to this explainer. I gotta tell you, I've been so incredibly excited to dive into this one with you because today we are setting the stage for an exploration into what is, without a doubt, one of the most mind-bending, thrilling, and frankly downright maddening concepts in all of time travel. If you love puzzles that seemingly have no start and no finish, you are in the exact right place.
I want you to picture this for a second to really hook your brain into this thought experiment. Imagine you discover a time machine. You hop in, you travel to the past, and you hand Albert Einstein his own famous blueprint for a groundbreaking invention. Then, years later, you find that exact same blueprint sitting in a historical archive, travel back, and give it to him again. The impossible question staring us right in the face here is, who actually created the blueprint? We can't say it was you, because you grabbed it from history. But we sure can't say it was Einstein, because you literally just handed it to him.
So, what exactly is a bootstrap paradox? Let's unpack the core concept we're untangling today.
In formal terms, it's known as an ontological paradox. But basically, a bootstrap paradox is a closed time loop where an object, or even just a piece of information, is entirely self-created. It has absolutely zero discernible point of origin. I actually love where the term itself comes from, by the way. It's a nod to this totally absurd 18th century literary tale about Baron Munchausen, a character who supposedly saved himself from a swamp simply by pulling himself upward by his own bootstraps. It's an impossible, ludicrous action, which honestly is the perfect metaphor for what we are looking at.
The legendary sci-fi author Robert A. Heinlein really put this idea on the map back in his brilliant 1941 story, By His Bootstraps. In the story, a guy named Bob Wilson is handed a dictator's notebook by his future self. Wilson later uses that exact notebook to become a dictator himself, copies the worn-out text into a fresh notebook, and then hands it back to his past self. As Heinlein's character realizes, there were never two original books. So who actually wrote the book? The information just exists, permanently suspended in this weird circle.
Now, you might be wondering how this crucially differs from other time travel tropes you've seen. Take a consistency paradox, like the famous grandfather paradox, where you go back and stop your grandparents from meeting. That inherently breaks history, right? It creates a massive contradiction. But a bootstrap paradox, it doesn't break history at all. It actually creates a perfectly closed, deeply consistent, yet completely unchangeable loop. Everything happens exactly as it always has.
Moving on to cinematic loops, objects, and info. Let's see how pop culture uses these loops to completely bend our minds.
Hollywood writers absolutely love this stuff, and they usually drop these paradoxes into three distinct buckets. You've got objects that circulate forever, information that has no original thinker, and, definitely the most terrifying of all, entirely self-created persons. Let's break these down one by one.
Starting with objects. Remember the beautiful 1980 romance movie Somewhere in Time? Christopher Reeve's character receives a pocket watch from an elderly woman in 1972. He then travels back to 1912 and gives that exact same watch to her younger self. She keeps it for 60 years, only to hand it back to him again. That watch was literally never manufactured in a factory. It simply exists because it always existed. We also get a really fun version of this in the 1989 comedy Bill and Ted's Excellent Adventure, where they desperately need keys to break into a police station. Bill decides they'll just travel back in time later and stash the keys behind a sign. They look behind the sign right then, and boom, the keys are already there.
Okay, let's escalate things to information loops. Think about the killer AI, Skynet, from the Terminator franchise. Skynet sends a cyborg back in time, and that cyborg gets crushed. Then in Terminator 2, a scientist named Miles Dyson recovers that futuristic CPU chip and reverse engineers it. And Dyson's research becomes the literal foundation to build Skynet in the first place, which means Skynet's existence is caused by Skynet sending its own hardware into the past. It's a closed loop with absolutely no human inventor. The killer robot is its own ancestor.
We also see this incredibly elegant information loop in the brilliant German sci-fi series Dark. Right at the center of its universe is a book on time travel theory written by a clockmaker named H.G. Tannhaus. But here's the catch. Tannhaus only writes the book because a finished copy of it is handed to his younger self by a time traveler from the future. Young Tannhaus just copies the future book word for word and sends it off to a publisher. The text has absolutely no original author anywhere in the chain. It's pure, unadulterated, bootstrapped information.
Which brings us to the ultimate loop, human existence. This is what happens when the looped object isn't just a watch or a book, but an entire human life.
Buckle up for this one. Let me walk you through the mind-bending narrative of the 2014 movie Predestination,
which is based on another Heinlein story. We start with a woman named Jane. Due to medical complications, she transitions and lives as a man named John. A time-traveling agent takes John back into the past, where he meets and falls in love with the younger Jane, who is his own earlier self. That relationship produces a baby. The baby is abducted, dropped out an orphanage in the past, where she grows up to become Jane. Following that all the way around lands like an absolute hammer. Jane, John, the baby, the time-traveling bartender, and the terrorist they are all hunting known as the Fizzabomber, they are all the exact same person. It is a single human being who is their own mother, their own father, their own child, and their own enemy. A complete family tree folded totally in on itself into a single dot.
All right, breaking physics, causality, and entropy. Let's shift away from movie magic and look at the hard science of how these loops seemingly shatter our fundamental understanding of the universe.
The real kicker here is that a bootstrap paradox utterly obliterates the law of causality. We are all raised on the simple idea that a past cause leads to a future event, right? But in a causal loop, that origin point is just erased entirely. The event was created in the future before leading to its cause in the past. It suggests this wild, terrifying reality where time isn't just moving from a dead past to an undetermined future. Instead, the past, present, and future are all equally real, and they are kind of happening all at once.
But wait, we have a glaring, massive problem in physics here, and it's called entropy, the second law of thermodynamics. This law basically states that systems always flow from order to disorder. Things naturally break down over time. So think back to Christopher Reeve's pocket watch circulating infinitely through time. Even if it travels through time, its physical matter is still aging. If it loops infinitely, it should continue to age, wear down, and eventually turn into absolute dust. How on earth does it survive the loop without just disintegrating?
Enter the Novikov self-consistency principle. Let's explore the scientific rule that might actually allow these loops to exist in reality.
So back in the 1980s, Russian physicist Igor Novikov developed a principle that's sometimes called the law of conservation of history. Novikov argued that if an event exists that would cause a paradox or change the past, the probability of that event happening is strictly zero. In plain English, any events on a closed time curve are already guaranteed to be globally self-consistent. The universe physically will not let you create a contradiction.
But you know, physicists absolutely love a challenge. So Joseph Polchinski comes along and proposes this famous thought experiment to try and break Novikov's rule. Imagine a billiard ball fired into a wormhole. It's angled perfectly so it exits in the past, rolls across the table, and smacks into its younger self, knocking it off course so it never even enters the wormhole in the first place. A perfect, simple grandfather paradox, just using an object. Does this break the universe?
Well, two physics students at Caltech, Echeverria and Klinkhammer, completely solved this paradox. They did the complex math and found out that the ball from the future couldn't emerge at the exact angle to knock it entirely away. Instead, it emerges at a slightly different angle and delivers just a glancing blow to its younger self. And get this, that specific glancing blow alters the younger ball's trajectory by exactly the right amount, forcing it into the wormhole at the exact angle required to go back in time and deliver that very same glancing blow. The universe literally self-corrects perfectly to fulfill the loop.
Okay, but what about the pocket watch and the whole entropy problem? Novikov actually addressed this too. He pointed out that the second law of thermodynamics is statistical. It's not absolute. Spontaneous entropy reversals are incredibly improbable, sure, but they aren't totally impossible. Plus, think about it. That macroscopic pocket watch is interacting with the outside world. The environment around the watch is actively expending energy to repair the wear and tear over its history, essentially restoring the object to its original condition so the loop closes perfectly intact.
So, what does this mean for you and your perceived free will? If the universe actively corrects billiard balls to prevent paradoxes, what happens if you go back in time and try to change things? The physicist J. Craig Wheeler summed it up brilliantly. He pointed out, physics already restricts your free will every day. You may will yourself to fly or to walk through a concrete wall, but gravity and condensed matter physics dictate that you cannot. Why would a consistency restriction placed on a time traveler be any different?
Which leaves us with one final, profound question to wrap up today's explainer. If time machines exist, and the timeline is a completely fixed, self-created loop that physically prevents us from altering the past, does free will actually exist? Or are we all just playing out perfectly scripted, predetermined roles in a closed causal circle, moving on a track we can never ever derail? It's definitely something to chew on the next time you find a set of keys placed exactly where you needed them. Thank you so much for joining me today, and keep asking those impossible questions.